This is the solution to Mechanical Science, Sheet 5, Question 1. So we have a ladder here inclined against the wall. The ladder makes an angle theta with the ground. So before we get onto the talk, we're going to start with the forces. So we've got here mg is equal to the reaction force. That makes sense. That should be fine. The up force equals the down force is basically what that says. So we from the question, we know that failure happens when the ladder slides. So that would happen when the reaction force from the wall, Fa, is greater than the frictional force, Ff. So look at that carefully. We've got Fa pushing away from the wall and Ff pushing towards the wall. When Fa is greater than Ff, we have failure. So that means the limit is when Fa is equal to Ff. That's one of the keys of this question. Fa is equal to Ff, and that's our limit. So from there we can continue and we say, okay, we know the equation for the frictional force, Ff, is equal to the reaction force multiplied by mu. So we can say Fr multiplied by mu is equal to Ff, and we know that Fr is equal to mg from before. So we can say Ff is now equal to mg multiplied by mu. And we also know that our Fa, reaction force from the wall, which is up there, is equal to mg mu because of Ff being equal to Fa. So just get that in your head so it's clear. This is like some initial equations that we've done here. So we're going to continue on, and we say the reaction force Fa acts at a distance of 1, like the whole length of the ladder. So Fa multiplied by 1 times sine theta is equal to mg, which is our mass, which acts at half the distance. So we multiply it by half, and then cos theta. So that's cos theta. The reason we use sine theta here is because, like we said before, we have 90 degrees. So we know that Fa acts at an angle, and it's a certain angle away from the parallel line of our ladder. So that's why we use sine instead of cos. And even though Fa is at that top angle there, not this bottom one, if this is theta, this angle is 90 minus theta. And so where Fa is acting from the parallel line is in fact theta again, if that makes sense. Or you can think of it as this angle being inside this triangle is going to be the same as that one at the top of that triangle. We can go into that a bit more detail if you need to, but the long and short of it is you use sine theta in this case, and we've got cos theta over there. So we can rearrange that to have Fa is equal to mg cos theta over 2 sine theta. And that simplifies to mg over 2 multiplied by 1 over 10 theta. And once again, we can use our equations from before. So we say that Fa is equal to mg over mu. So if we do Fa over mg is equal to mu, we can basically divide that equation above, well, this equation here, by mg, and we end up with mu is equal to 1 over 2 tan theta. And so we can multiply our mu by 2 and then invert it to end up with tan theta, and then do 10 to the minus 1 of 1 over 2 mu, and we end up with just theta. And that should pretty much solve the equation, the problem. I'm going to zoom out a bit so you can have like a full look at it. But yeah, if there's any questions, make sure you send me a message and we can go through it again.